So we purposely put Stefan on last so everyone would stay. So our last speaker is Stefan Niemann from the National Reference Center for Mycobacterium, and he's going to talk on multi-drug resistant transmission and evolution, implications for treatment and assay development. Stefan.
Yeah, thank you very much for the invitation to come here and all the previous speakers to keep in time. So I'm going to hopefully speed up a bit. So I want to give you some thoughts on concepts of resistance development, understanding the MDR epidemic and what that finally means. So what we heard about resistance already is that it's just a single nucleotide change, and that is usually thought to be coming from random genetic variants that are selected via ineffective treatment, but when they're fixed in the chromosome, they can be transmitted. And there are a lot of variants that we could look at, and the composition of mutations in some patients can be highly complex. So from a point of view, the target gene actually defines very much if we are going to a very narrow target and a low number of mutations, or we have another target that actually has a high number of mutations. So that's the first implications when we design assays, so that we can actually look into a variety of mutations or just few. So the number of resistant variants and the mutation frequencies, of course, depends on the genomic regions we're going to look at. So what is transmission doing then? So basically, when you come with random fixation, then you presumably have the similar chance that the mutations occur across the gene. When it comes to transmission, presumably some mutations are more favorable than others. And if you have clonal expansion, you're just in an area having one particular mutation that can either escape a diagnostic test or also give rise to completely different treatment regimens. And the ratio beyond these actually defines very much what mutations and what drug resistance patterns you do find in a certain region. And actually the question of MDR transmission was for a long time completely neglected, and the most people thought that because of the negative effect this has to fitness of the strains, basically transmission is not the dominant factor and we need to just keep this under control, so no more resistance mutations. So the transmission of resistance mutations strongly impacts diversity of resistant patterns in a given population. And even more than these mutations, just when they are fixed in the chromosome, could also be linked to mutations in other genes. So basically, you have a linkage of an INH mutation or a KG mutation with a RIMFA-PC mutation. So in the chromosome of a given strain that is then transmitted, you can find a number of mutations. The final question then is how many mutations a strain can acquire and still can be transmitted efficiently. So that also has implications for TP control of pre-XDR or MDR strains in a given area. And the transmission in linked sets of resistance mutations can, of course, lead to the transmission of MDR or pre-XDR strains. So why do we think that actually the fitness of resistant strains is less than those of susceptible strains? Because the mutations target important regions in the chromosome, and there were initial experiments, and these are experiments done in Borstel in 1950, where the first INH resistant strains were detected, and Gertrud Meissner then did experiments in guinea pigs, and the white bars here are a disease score from experiments with susceptible isolates, and you can see that the disease score goes up, and then here at this time point all the animals were dead, while this was not the case for INH resistant strains. And there were some more experiments like that actually giving rise to the assumption that the longitudinal impact of TB, so the MDR, would not have a longitudinal impact on the TB epidemic, and transmission of those strains could be neglected. Pretty much in the first years I worked with TB, we came across that this is not necessarily true. So here you can see actually an example of a patient with this initial sensitive strain that got a reinfection under treatment with an MDR strain. So there was, I think, reported in 1997, there was a nice meeting in Berlin in 1998 where we actually posed already or suggested that we don't see a general rule that MDR strains could not be transmitted. And basically, I think hospital transmission is one of the major drivers of transmission. And that's I mean, that, of course, this was a German hospital. I'm not generally disclosing where that was, but there was actually both patients finally died from TB, and actually the susceptible, or the patient with a susceptible strain initially had a family with 2 children, and there was a movie in the German television at that time, and that was really a disaster, showing that even you have a low incidence of MDR-TB, the single events that could easily be avoided is a very tragic thing. So then, how can this be explained? And this is a cartoon from Sebastian, who is in the room. So basically the idea then was, okay, yes, you have a sensitive strain, it gets resistant, so it basically drops fitness, but suddenly it starts to compensate that, so it evolves towards a higher level of fitness again, and this can be the same level than before or a higher level, so basically you can also climb up to a higher level than you had previously in the terms of fitness. And there are also then resistance mutations that may initially not have that much of a fitness cost, and in addition you would have compensatory mutation, so favoring that. So what finally then actually addresses the question, so is MDR-TB in 10 years the kind of TB that we are dealing with overall? Is the 3 questions. First of all, is transmission important for the MDR epidemic? Is the number of mutations limiting transmission? So do we get a certain window of transmissibility, but then, I mean, at the end, all this pre-XDR stuff is not longer more transmitting? And can we also define back, or look back in history, what caused the clonal outbreaks of MDR strains? So what we actually usually do is we do mol epi experiments, and I explain slowly or shortly what that is. So basically, when you want to learn if one index patient has infected some other patients, then you usually do contact tracing investigations, you look at epi data, and that very much depends on reporting quality. So we are coming from the pathogen side, we are doing typing, so that actually by just typing all strains in a certain area, we can actually disclose transmission, or we can refuse transmission. And of course, that is a bit depending on the pathogen, on the culture, on the DNA. So we need to do genotyping. So here you have reporting quality problems. Here you have, of course, you need the sample. And of course, because we are now in the NGS world, we actually started to do that using genomes, and that's presumably the only picture you can get from me in the laboratory. That was just for a newspaper. Because now I'm not longer more allowed to work there, or even not go into that. So, yes. So then we actually, I mean, I skip a lot of nice slides that I usually show. I'll just come to one study we did in the Aralsea region. This is a classical tree, so Mairu, VNTR typing, and this is the population structure of the strains you see. Then a lot of them are Beijing strains, and the big bubble here is actually showing that all of these strains are identical with Mairu typing. And when you plot resistance mutations on that tree, you can see that a lot of them actually have the same pattern of low fitness cost resistance mutation. So that already indicated, well, this is transmission. So a lot of people found that this is a common type 9432, this is 10032, it's found across all over Europe, but what doesn't tell us, because Mairu typing was a bit like thought to have not the resolution power to address transmission. So then we did the genomes, and this is a genome phylogeny, and you can actually see that these are the 9432 strains, and actually in those we then could see something that we term Central Asian outbreak strain, and this increased over time, which in these MDR populations, so the starts from 2001 to 2006, you can still that we are a bit lazy because we right now analyzing strains from 2011 and 2012. So, but when you then plot resistance mutation on this tree, you can see that the most successful strains are completely resistant against first-line drugs, and in addition have acquired a high number of additional drugs. So these ones are really resistant to 7, 8, 9 antibiotics, and in addition they acquired on the side here what maybe explains transmission, so-called compensatory mutations. So basically these ones are more or less fully resistant. However, I must also point out that if you look for PNCA, for example, there are groups of strains that actually are susceptible, and those would, of course, benefit when you do an individualized treatment regimen from inclusion of pyrazinamide. And similarly, for some other drugs like etambutol, you have also groups of these outbreak strains that actually do not have resistance mutations. So here, of course, a refined diagnostic then would help. So in addition, we calculated something that we termed transmission index. That is basically the transmission network. One strain is linked to other strains in just a very short genome distance. And that also shows that the number of those strains with the highest number of mutation actually are also involved in the highest number of transmission networks. So are basically all related. So it's ongoing transmission, and those ones are also highly transmitted. So then we took another data set that is from Samara, so in Russia, so basically a bit further away, to see, is it just in one area or is it a phenomenon in another area also? And this is just directly the genome phylogenetic tree, and you can see 3 major clones that actually cause more than 80% of the MDR strains in the region. So these are 700 MDR strains, and again, the transmission indexes of these dominant clones are really high. And also, first-line resistances, like here, for example, pyrazinamide, in the clade A clones is close to 90%. So you actually ending up with highly resistant transmissible clones. Similarly, they have acquired second-line resistance mutations to a high extent. And again, there are, of course, always in between individual isolates that do not have a resistance mutation. So there, again, a diagnostic and an adapted therapy would at least benefit the patients. This is just one point I want to make, is when you look into compensatory mutations, you can see that they, first of all, when a clone acquires one mutation, it does not necessarily acquire another one. So showing the clear-cut effect of the mutation. And there are mutations in RPUB that compensate for a resistance-confirming mutation that are equally important than mutations in RPUC. So you can see that here are RPUB compensatory mutations here also, and this major clone here has an RPUC compensatory mutation. So that basically explains the transmissibility. But this shows actually that at least in Eastern Europe, the MDR epidemic presumably is largely clonal and dominated by few clones that have specific characteristics. So just to give you another example, this is TB in Swaziland, and this is resistant and susceptible strains. So the population diversity in general is quite complex, and here you also do see Beijing strains that are over here. So when you then plot MDR on that, you can actually see the red dots are MDR strains. So this is not diverse. So this is just mainly restricted to 2 clones, one of the S and one of the X type lineage, were not among the Beijing strains. And what that meant, so that was published last year in the New England Journal, is actually that this clone, one of these clones that represents 30% of the MDR cases there, has an RPUB mutation that is outside the 80 base pair region, is not detected by the gene expert. So that was quite a frightening example that actually shows that the clonal expansion of a certain MDR strain actually could abolish the efficacy of a certain diagnostic assay. So we are actually following that up, so we're trying to get more strains from the region, because now as the Cepheid system or the gene expert is actually put out as a primary diagnostic measure detecting MDR-TB, so these strains presumably has a massive selective advantage in the region. And MSF, for example, has taken that into account, and they are now working on other rifampicin test systems like thin layer agar tests to see if this works out there and patients can then be treated. And I just want to stop with one example in Germany. So just recently we detected the first MDR outbreak in Hamburg, and that was actually 5 cases that appear with a Beijing strain infection, and like previous years, we were quite sure that these were imported cases and not linked in Germany. However, when we did the genome, though, the four strains were completely identical, and one strain was just one SNP away. So then we did contact tracing investigation. Actually, it turned out that the index case was a Chechenian refugee that had an open pre-XDR-TB, as you can see here, for 2 years, that traveled around in Hamburg frequently and infected 3 further foreigners and 1 German, and the German actually reported no contact. So we are actually, you can also see that this resistance is quite complex, so pre-XDR, and here also what we did, actually 2 of the patients were treated in Borstel and got an NGS diagnostics to improve the treatment. The other case is similar, though that is a transmission in the family where we actually also foreign people, and the husband actually infected his wife, and the wife was diagnosed, and then the husband with the MDR-TB. So in conclusion, one could say that there are extreme bottleneck effects via antibiotic treatment that led to the selection of few MDR outbreak variants. The MDR epidemic, at least in Eastern Europe and presumably in parts of Africa, and not shown the data from Rob and the colleagues from South Africa, but that is similar, are highly clonal, and there are few MDR strains or pre-XDR phenotypes that are super transmissible, and the main reason for that is compensatory evolution. And I think that the presence, of course, can impact diagnostics, but also treatment regimens, because you can actually predict from the patterns of the dominant clones which treatment regimens might be effective. And overall, I must say that in Germany, of course, we are going forward to do individualized treatment based on the profiles we do based on genomes or resistance testing. I would like to thank my group and the lots of collaborators, and several of them are in the room, and thank you for your attention.
We're right on time, so one more question.
Thank you. William Wells from USAID. Thanks for a fascinating talk. So you talked about the compensatory mutations, but I'm just wondering, do you have enough evidence to say how much of this extra transmission from these highly mutant strains is due to fitness issues as versus the failure of those strains to respond to treatment?
So we did statistical analysis correlating or comparing the number of resistance mutations in strains with compensatory, without compensatory mutations, and there was a statistical difference. So the ones without just acquire 2 or 3 resistance mutations, and the others got 6 to 7. And similarly to transmission networks. So the strains with compensatory mutations usually have transmission networks higher than 30 to 50 neighbor strains, so indicating that they are really, I guess, involved in higher transmissions. And that was not the case for MDR strains without compensatory mutations. That basically indicates that the transmissibility is not equally distributed among MDR cases. So basically, from a basic assumption, when MDR would be the driving factor for transmission, then that should be equally distributed, but it is not. Rob.
Stefan, you use the term outbreak.
Yeah.
Do you feel that's the correct term for what we're observing in your studies as what is being seen in South Africa?
So in German we would say Jein. So did you know what that means? So we actually dated the outbreak. Because I thought I can only speak 15 minutes, I have not included that here. So the Central Asian outbreak and the ABC clones of Beijing, they actually are 25 years old. And 25 years ago, they had already these 6, 7 resistances. So they were fixed in the population already 25 years ago. And what we then did is we calculated Bayesian skyline curves to actually see the success over time. And there were different time points where actually the success increased. So the initial fixation or going to getting compensatory mutations and 6 resistances increased the success. Then the implementation of DOTS and DOTS Plus gave another success push, so to say, because presumably without proper diagnostics, blind treatment on a previously resistant strain population strongly selects for those that are actually resistant. And that is something you can clearly see. So it is in Central Asia right now an ongoing epidemic transmission and an outbreak, and a 25 years old ongoing under the radar event. For the Swaziland clone, it's 15 years. So we calculated an age of 15 years, but at that time the strain was already 6 times resistant. So it's kind of a mixture.
Epidemic versus...
Yeah, you might, I mean, in TB you might say, okay, what is an outbreak? So in Hamburg, the susceptible outbreak we measured is also occurring over a period of more than 10 years. So the strain is still spreading. And so the question then is, I mean, is it still an outbreak or is it kind of, well, we cannot get rid of even these susceptible strains.
Okay, I'd like to thank all the speakers in this session. It was a great session. Thank you all. And I think Marco has the final.